Thanks, Miranda, and hi, everyone. It's the last talk, but I'm speaking about the entire NSERC, IRC, and swine welfare, so there's plenty of variation there, so hopefully we'll keep it interesting for you. So yeah, this is basically an update on what the program has been doing for you, the tools that we've been delivering, and the results that we have so far. So just to give a little bit of background into the importance of the program and why it was set up. So when we think about the past and current pressures that are facing the Canadian swine industry, for example, the move to group housing for sows and long distance transport, well, those pressures, the response to them has not always been informed by science, which can often lead to requirements that are not workable for the industry, not practical. And because these can influence market access, that can really put the industry at a disadvantage. So that is why the chair was put in place. It is a strategic initiative to bring you proactive research, proactive responses to those pressures that we have, and really develop practical solutions for the industry. And the chair has put infrastructure into place, so a large team of highly skilled individuals to work on the challenges that are present, and to make sure that these challenges, we develop solutions that are actually workable for you and practical for you. So it really increased the training of highly qualified personnel in Canada and increased the research potential. And the team we're skilled in animal welfare, but we also understand the industry's needs, so we can really make those solutions practical for you. So the program was established in 2018, and the total funds for it are $2 million. And the money comes from 14 industry partners, the federal government, and also the University of Saskatchewan. So all of those are represented here on the slide. And this slide here shows you the breadth of research that we've covered between 2018 and 2023. So we've looked at areas such as sow management, we've looked at questions on the growing pig and how to support its lifetime welfare. We've developed welfare assessment protocols, looked at environmental enrichment for all of the stages in production, and we've also validated some biomarkers for measuring welfare, and then looked at swine transport as well. So this really shows you the skills in the team and the diversity of the work that we do. But more specifically, the NSERC program is really designed to answer two overreaching objectives. So the first one being looking at what beneficial pathways can we follow to support the pig in fully slatted systems in terms of its welfare. And in this case, we are answering that question with goal 1 and 2. So goal 1 looks at the contribution of early life management to pig robustness, sociability, and welfare. And then goal 2 identifies whether, firstly, can we promote play behavior in intensive production systems. And then we want to identify as well whether those play behavior occurrences, do they have any beneficial effects on the pig's physiology and also their psychological robustness. And then the second area that we're looking at in this program is to really provide the industry with tools to monitor and measure welfare, to help equip the industry with high quality welfare data that they can use to their advantage, for example, in increasing the transparency in reporting and building the consumer trust. So that is answered by goal 3 and 4. So in goal 3, we are validating different biomarkers of welfare and stress in pigs. And then in goal 4, we are looking at the value of carcass assessment as a measure of welfare for the pigs on farm and in pre-slaughter handling. So now I'll just give you an update on each of the specific goals in terms of the work that's been done and the results that we have. So starting with goal 1, this looks at the contribution of early life management to pig robustness, sociability, and welfare. And this work goes off the idea that the early life development of the pig is really critical to how that pig copes with stress later in life and what its welfare is like later in life. So what we're trying to do with this project is optimize the welfare in fully slatted systems early in life through different early life management modifications to really support that lifelong welfare effect, which also contributes to productivity of the pigs. So what we did here was we provided the pigs with a combination of treatments in both farrowing and in nursery, and the enrichments and the sort of modifications to their environment that we've provided included chewable materials such as the rope around the creep feed, as you can see here, and this was to support natural behaviors such as mastication, and potentially also improve the pig's coping at weaning, because we know weaning is a very stressful period for the pig. We also introduced some human contact, so positive human relationships to reduce the pig's fear of humans and potentially improve its handleability. And we also gave them extra space in the farrowing crate, so providing room to develop social behaviors, let those pigs get away from one another if needed, and really develop those social skills. And we did this by opening up the door to the farrowing crate. And that makes sense because the litters are so much larger now than they used to be. So just giving them extra space even helps. So all of that together, this approach aligns with the pig's natural needs. And so it is thought to confer benefits to their welfare, but also benefits the industry potentially through improved robustness, sociability, resilience, and overall improved welfare. So if we look at the results that we got in this study, firstly we saw improved average daily gain in nursery, and also we saw that lifelong effect in this measure, and this was in the pigs that were reared with those early life management modifications. So what we think was happening here was, since we provided the chewable materials at both farrowing and in nursery, that potentially had an effect on the pigs being more adaptable at weaning, so they probably had an easier time being transferred onto solid feeds since the chewing behavior was already supported in them. And by providing the treatment both in nursery and in farrowing, we had a sort of combination additive effect on the welfare, and that is why we think we saw an effect also on the improved average daily gain throughout their entire life. We also saw reduced skin lesions at mixing in those pigs, so that is suggesting to us better social skills in those pigs, and also just overall better welfare, less stress, so less fighting, less injurious behavior. And we also saw that they did have improved handleability, so they were less reactive in the late nursery stage. So again, that's those social skills, and also that positive relationship with humans, less fear. We also saw that there was a lower proportion of bitten tails in the treatment pigs at the end of the nursery period. And again, that is pointing towards the benefits of that chewable material. So having the chewable material probably distracted the pigs away from the tails of the pen mates and helped them express natural behavior and redirect the damaging behavior onto more appropriate objects, such as the rope that we gave them to chew on. So to understand the mechanisms sort of behind tail biting, we also measured gut inflammation levels, and here we looked at cytokines and calprotectin. And this is really to understand the interaction between the treatment and the treatment's effect potentially on the immune response in the pigs, and what contribution that is making to the tail biting. So the analysis of that is currently in progress, and we're also currently analyzing the carcass traits of those pigs. So that is coming in summer of 2024. So overall, if we think about those results, we saw improvements to the pigs' welfare through improved social skills, robustness, sociability, less fear of humans, so less stress, and all of that translated into improved average daily gain and less damaging behaviors, which are all areas important both to the pig and the industry. So it is something that the industry can benefit from. Moving on to goal 2, this work is a sort of blue sky area where we are looking at supporting positive welfare, and in this case we are doing that by looking at play behavior. So historically, producers have been asked to reduce the negative experiences in the pigs' lives, which includes things like castration, tail docking, and diseases. But now we're all encouraged to really focus more on also including positive experiences in the pigs' lives. So that includes things like fostering a good animal-human relationship, allowing the pigs to form social bonds, since they are social herd animals, so they do like to be together and have good relationships. And we can also look at play opportunities, because play is a rewarding experience for the pigs, and it only really occurs in pigs that are of good health and good psychological state. So it's also a good potential welfare measure. So in this work, we wanted to know how to provide those play opportunities to the pigs, first of all. So we wanted to determine, can play really be supported and triggered in intensive production systems? And then also, what are the conditions that are needed to trigger the behavior? So here we tested the provision of positive events, such as, for example, enrichment materials, or also extra space allowance to the pigs, to see if that would encourage them to play. And then we also tested the benefits of the behavior on both resilience and productivity of the pigs. So just to explain the methods so that you have an understanding of how we actually tested this. So play pigs in the play treatment were reared with play opportunities from birth, whereas the control pigs had no play opportunities at all at any stage. And then at weaning, both pigs from the play treatment and the control treatment were selected for a disease challenge to test the effects of the behavior on health and resilience. And so they were transported to a biosecurity level 2 unit, where they were challenged with the PRRS virus. And so throughout the infection period, we looked at the pigs' rectal temperatures, their weights, we collected blood from them, and we also checked their respiration rate daily. And the play pigs in the play treatment were still provided with play opportunities, but now this was done every second day. So if we look at the results here, so first we have skin lesions, which we used as a measure of aggression. If you just focus on the weaning period for now, so here we can see the control pigs, the blue line, and the red line is the play pigs. So there was not much difference in the level of skin lesions between the two groups at weaning. But then if we look at the time of transport, so mixing and where aggression happened, we see that the play pigs actually had much lower levels of skin lesions during transport. And this level also remained much lower than until the end of the trial, whereas the control pigs were much higher. And so again, that is suggesting better social skills in those play pigs, less injurious behavior, less fighting, and potentially also the fact that those play pigs were feeling less sick, so perhaps they were less ticked off and didn't want to fight with the other pigs. They were not as grumpy. So then if we looked at the PRRS viral load, this is only a tendency, which means there was not a significant difference between the two treatment groups. So the level was higher in the play pigs, but this was not a significant difference. And then in terms of the sickness behavior, we saw more activity in the play pigs, both during the infection period and also throughout the, or rather before infection, and then throughout the entire period of infection until recovery. And in this case, we can, based on that, we can tell that, again, those play pigs perhaps were not feeling as sick, and that likely translates to a better immune response, more efficient immune response. So they were showing less sickness behavior. And that then translated onto the monocyte levels in the play pigs. So monocytes are a measure of the immune response. They are the white blood cells, which are a component of the immune system, and they're really the first line of defense when it comes to a disease challenge. So with the play pigs, we had lower monocytes, which means a lower inflammatory response. But that doesn't mean that this response was not effective, because if we look at the graph, the play pigs actually returned to a baseline level at day 21 post-infection. So even though the immune response was lower, it was still just as effective when we compare it to the control pigs, which kept going up in terms of their monocytes. And then the lower inflammatory response in the play pigs also translated into fewer clinical symptoms of the PRRS virus in the play pigs. So we see a lower probability of those pigs being in respiratory distress throughout the study than the control pigs. And then finally, the average daily gain as well in the study was improved in the play pigs in the second half of the infection period. So what we see here in this graph is that the play pigs actually performed above the level that we would expect for pigs of 25 kilos, whereas the control pigs were slightly below that expected level. So again, those play pigs, likely less stressed, improved immune response, less sickness behavior, and all of that translated onto better welfare, better resilience, and health when you compare it to the control pigs. So again, the implications of this work for both the science and industry, well, we did see improved overall welfare, better health, and that translating into improved average daily gains, so productivity measures, which is of importance to both the pigs but also the industry. So again, you can benefit from facilitating the play behavior in pigs. But also implications for science. We did show that play behavior can be promoted in intensive production systems. It is a positive experience for the pigs, so it's also a good measure of positive welfare. And in that sense, it could have implications for the code of practice. It could be used as a potential measure of positive welfare. And it's also an important tool to support good welfare and really maintain that positive image of the pork production, as positive welfare is something that is increasingly being asked for of us. So this is good news, in my opinion, because play behavior, as you saw, it's not that difficult to implement it, and it does have some beneficial effects overall for the pigs and the industry. So moving on to goal 3 now, this switches the focus of the NSERC. So now we're trying to answer that question of providing the industry with practical tools to measure welfare. So here in this project, we validated biomarkers of welfare states in pigs. And we're specifically looking at biomarkers which indicate biological states. And up to this point, we still actually don't have many biomarkers of stress and welfare in pigs. But it is important to research this area because they are a more objective measure of welfare, so we can use it to differentiate the welfare of different production systems, also to tell welfare at individual animal level, or it could also be used as a tool for genetic selection. So in this work, we specifically focused on hormones in hair, and hormones in hair provide a chronic measure of stress. And that is because the hormones that we have in the bloodstream, as the hair grows, those hormones from the bloodstream get incorporated into the hair shaft. And then when we shave that hair, we can extract the cortisol or whatever other hormones we have in there, and we can analyze their levels, and that informs us on the levels of stress experienced by the animal in the past. So that counts from weeks or even months previously before shaving the hair. So the specific hormones that we looked at included cortisol and DHEA, and also the ratio of both to each other, because that's been suggested as a superior measure of stress and welfare in animals. And the student working on this project also validated the procedure for washing the hair and also for the hormone extraction from the hair to ensure that the results we get from this work are actually reliable and truthful. So the chair also provided resources, put infrastructure in place really to investigate into those measures further. And so in this specific study that you see here, we wanted to give extra weight to that ratio of cortisol to DHEA as a reliable measure of welfare. And so this study here looked at the interaction between the immune response and the stress response. And what they found here is that both are actually heritable, so immune response and stress response. And so the specifics of that, cortisol and DHEAS are both heritable phenotypes in young pigs, which means that they can be a potential biomarker to select the pigs on in terms of how they cope with stress. So what we also saw in this study, when comparing pigs from environments designed to improve welfare and modulate stress, so for example, by providing them with straw and management modifications in early life, so those treatments that I described in Goal 1, when looking at those pigs compared to pigs reared in a conventional environment, we didn't see any difference in the system, so no system difference in hair cortisol and DHEA levels. But then when we look at it further and we look at the actual individual animal level, we did see differences, especially when the pigs were undergoing a major stressor, so for example, lameness. So here we saw that pigs that were lame in the conventional system had a higher cortisol to DHEA ratio. And what that tells us is that those pigs from the environment designed to modulate stress and welfare were better able to cope with stress as opposed to those pigs in the conventional system. And that also gives weight to that ratio of hair cortisol to DHEA as a reliable measure, specifically for individual pig welfare assessment. So this slide here really just confirms what we found. This is a study that was done before ours, and it really aligns with the results that we got. So again, here we have pigs reared in conventional systems compared to pigs in a multi-suckling environment that was enriched and also had larger pens. So in standard conditions, when just comparing the two systems, there's no difference in cortisol between the two groups. But then when we stress the pigs with a range of different stressors, so you can see here transport, LPS challenge, heat stress, that's when we start seeing differences. So the conventional pigs had much higher levels of cortisol again, as opposed to those alternative system pigs. So that was Goal 3, and now finally moving on to Goal 4. So this is the project that I'm specifically involved in as a postdoc at the Vet College. So with this work, we are evaluating the value of carcass assessment to tell us something about the welfare of animals on farm and during pre-slaughter handling. And this work was really put forward as a response to the need of the industry for high-quality welfare data and a more practical way of measuring welfare than is currently possible with the farm welfare assessments. And why do we need high-quality welfare data? Well, I've already said at the start that this really helps us increase the transparency in reporting and also helps to build public trust so that people understand the pork is of good quality and safe, and it comes from animals that had good welfare. We can also use it to track on-farm management in our own operations. So are the management practices that we are using, are they effective or are they not effective? Do we need to change anything? We can use it to benchmark between different farms, and we can also use it to verify standards when creating animal care programs. So pig care is one example where that sort of data would be used. And also overall, welfare is becoming more important globally, and that's evident from different initiatives such as Prop 12 in the US, and also the demand for higher quality produce coming out of Japan. So people are asking for higher welfare increasingly, so it's good for us to have ways to prove that, yes, our animals do actually have good welfare. So to find a more practical approach to measuring welfare, we propose to perform the welfare assessment at slaughter. So this would be a complementary measure to the welfare assessments that take place on farm. And in this case, we would be using the carcass-based indicators that inform us on what's happened to that animal throughout its life, and that is how we can tell the welfare that it experienced. So we propose to have this system automated using artificial intelligence. And that really eliminates the human component from the assessment, which means the system would be less biased and also not a threat to biosecurity. And it would also help with the adoption of the technology, as it could be possible to scale it up to a larger commercial level. And it would be a more cost-effective method of efficient and continuous data collection. And the data coming out of that could be formulated as a feedback mechanism that would then come back to the producer and inform on the management practices and effectiveness of those on farm. So the objectives of the work, firstly, we want to identify the relationship between the animal-based welfare indicators on the carcass and relate that to the animal and resource-based measures on farm and in pre-slaughter handling to determine that as that herd diagnostic tool. So we want to know whether what we see on the carcass really predicts the situation on farm, on the animals in terms of their welfare. And as I said, we want to automate the system as well to make this into a more practical, useful tool for the industry. So in terms of the methods, we had a camera installed at an abattoir at a point post-scalding and deherring, and this was installed at a turn in the line. And that was specifically done to allow us to capture both the lateral and the dorsal side of the pig as it came up to the camera and it turned, so that we would be able to score the different lesions that are specific to sides of the animal. We collected footage on that, and that was taken and observed by 2 trained observers who scored the lesions on the carcasses. And the lesions that we included in the study, so we have fresh skin lesions, and that informed us on the aggression that likely took place during the transport period. So these are really fresh wounds. We looked at the tail length to inform on docking practices on farm, tail biting lesions, ear lesions. We also looked at hernia and frostbite. And then we had old skin lesions. So as opposed to the fresh skin lesions, this informs us on the aggression that took place on farm. So this would be an old scabby lesion, so likely happened earlier on before the transport. And then we also looked at human handling lesions, loin bruise, and bursitis. And each of those lesions was selected because each of them gives us a different piece of the puzzle and really informs us on the whole story of welfare of those animals on farm. So in terms of the automation of the system, that part of the study, we are working with the electrical and computer engineering team at the University of Saskatchewan. They are developing the system for us, so this is divided into several stages as it's quite a complex process. So I will run the video here for you. So as I talk about it, you can see different things happening. So basically the algorithm here is trained to detect the pig carcass on video and then track it using its ID as it moves through the video. And then it's also picking out the lateral and dorsal sides of the pig carcass based on its tail and head position. So these are the first 3 steps of training the model. And the results that we have for that are actually quite promising. We have very high accuracy, precision, and recall. So there is high potential of automating this successfully. The next step of that is to teach the model to recognize different anatomical regions of the carcass. So for example, the rump, middle, and also the head of the animal. So this is what that looks like in practice. So again, the algorithm is picking out the specific carcass, tracking it with the ID, and then picking out the sides and smaller regions within the sides. So that step is also complete, and we're also seeing very accurate results for all of the body parts. And then the final step in that is to identify the actual carcass lesions that are of relevance to welfare. So here we're both identifying the lesions and also quantifying them. And the specific lesions that we're looking at are tail bite lesions and also the tail length. We have the aggression lesions, so skin lesions, and we're also looking at the hernias. So that is currently in progress. We are currently training the mechanism to be able to pick those lesions out, but we have successfully trained it for hernia detection. So if you see it here, that's it detecting the hernias. Here's another one. So it does it based on the severity. So this is a mild one. I think there's a severe one coming up. Here, yeah. Yeah, so that's also complete in terms of this specific lesion. And then the final step is the actual skin lesions from aggression, and this is proven more challenging because of the shape and color variation of the lesion. So as you can see, it can really come in a variety of shapes and sizes. And the algorithm also has trouble differentiating between the actual lesions, and sometimes there's blood spillages on the carcass as well. So we need to find a way to really differentiate between that. So the approach that you see here is called color thresholding. So what happens here is the algorithm picks out the lesions that it thinks are lesions, and then it adds them up to tell us the total area of the body covered by the lesion. So this is currently in training, and we're constantly refining the model to do better and to really train it to pick those lesions out. So overall, the automation is looking very good. There's been good success in the results that we've been showing, and so there definitely is a potential for commercial level uptake of this technology. So that's all of the goals. So now just to wrap it up and really summarize what the chair has been doing for you and what you've gained from it. So with the results that I described, you can see that we've provided lots of information and tools for you as the industry to really take and employ to your advantage. And all of that work really helps to support the Canadian industry to be a leader in pork production and to produce better quality pork as well. And it helps to elevate Canada's options and conversation on animal care. And the team in itself that the chair has put together is quite adaptable and responsive. We do a lot of tech transfer through dissemination of the results that we have, organizing workshops, things like that. We're also always present at meetings, conferences. We're ready to talk with you and happy to answer any concerns or discuss anything you find interesting. So that plays into our consultancy work as well. And we're also active on social media now. So this was actually done at the request of the industry. So you wanted to have more ways to connect with us and also to increase our sort of output of information so that that is available to you. So these are all of the details. I'll also have that slide at the end. So if you'd like, take a picture and then later on connect with us online, we'd be happy to chat with you or discuss any concerns you have. The program itself is coming to an end this year, so there are now talks of renewing the program to continue with the work, and there's definitely interest in that. So that, first of all, demonstrates the swine industry's commitment to welfare, and the conversations are now happening between Dr. Yolande Seddon at USASC and the industry partners for the renewal. So as a team, we are continuously committed to keep delivering practical solutions for you as an industry. And at this point, since the program is up for renewal, we are asking for input on the research areas that are of interest to you. So do continue to let us know what you would like us to research so that we can keep answering your needs, basically. The next step in the NSERC IRC work, so now that we have all these results, we would like to support adoption of these results in practical commercial farm scenarios. So we want to move this work forward. And so again, if you are interested in participating in the adoption stage of this work, please do let us know. You can come to chat with me after the presentation or also use our social media channels to connect. But we would really like to implement the work that we've done in commercial production systems. So this is specifically goal 1, 2, and 4. So for goal 1, we would be looking to implement those strategic management modifications in early life. We would like to support play behavior in commercial systems and find a good way of provision of different enrichments and find what really works and what is economically feasible. And for goal 4, we want to test the AI technology that we've developed to ensure that it actually works in different abattoirs with different conditions. So this would involve installing cameras. And all of that we are hoping to achieve this summer. So do come talk to us if you are at all interested. We'd be happy to chat. And finally, as a large team, we have a lot of resources in place and a lot of skilled people. So we do projects other than just the NSERC IRC. So one project that we do have coming up is a project on sow mortality, where we will look at the risk factors for mortality, and we will also provide advice on mitigation strategies for it. So again, this is due to start in the summer of 2024, and if at all interested, please do come talk to us, and we would love to have some of you participate in this work as well. So that's it. This is really to acknowledge all of our program funders that have come together to fund this work. And thank you all for listening. And this is the team, so you might see some familiar faces there as well. Thank you.